So in this unit we're going to examine population dynamics. And in order to examine the population size, we're going to take a look at four different terms here: natality rates and mortality rates. Natality and mortality are opposites here, and immigration and emigration rates. When we put all these rates together, we end up with an S-shaped curve called a sigmoid population growth curve. And there's three parts to that. The first part is an exponential growth. The last part is the plateau phase. And we'll also examine the transitional phase that happens between those two phases. So to start us off, let's go ahead and define all four of these terms. The natality, or birth rate, refers to how often individuals are being born into the population, whereas the mortality rate refers to the death rate, how often individuals are dying in the population. The other two factors that affect population growth or decline are emigration with an E and immigration with an I. If we focus on population A on the mainland here, as individuals leave the main population, we call that emigration with an E. So emigration decreases populations, as opposed to immigration with an I increases populations, because it brings in new individuals. So usually a population that is very young starts out with a pretty high natality rate until the resources start running a little low, and then those natality rates, the birth rates, start decreasing until they level off towards the end. The mortality rates, the death rates, usually follow a similar pattern here, and in turn they'll end up decreasing, and once those resources start becoming more abundant, then the mortality rate will start leveling off as well. So for consistency's sake, we're just going to keep the birth rate in pink, and we'll refer to the death rate in blue. Because the total population is the sum of the natality and mortality rates, we're going to start off here towards the bottom, and when you take the birth rate, if it's higher than the death rate at any given time, then that accounts for a rise in population, until we get to the very top here, where you notice that in phase 4, that the birth rate and the death rate sort of balance each other out, so the population may have exacerbated its resources and it starts leveling off at the top. So in addition to natality rates and mortality rates, we have two other factors, emigration and immigration, that affect population growth. So in order to explore these two terms, emigration and immigration, we're going to revisit our classic example of placental mammals emigrating out of Southeast Asia along the islands of Indonesia, continuing on until they complete their immigration path into Australia. So emigration decreasing the population by leaving population X here, and immigration meaning that you are bringing in individuals into population Y down to the bottom. Once these mammals had arrived to Australia and populated certain regions within that main island, they started emigrating out to the adjacent islands. So we end up with two populations that are completely separate from each other. They're the same species, but they're separated by a reproductive barrier, the ocean. And given enough time, this population of the same species on the adjacent island ends up turning into its own species, shown in dark orange here. So emigration and immigration are not only the cause for population changes, but also account for speciation. So when we account for all four of these factors, the natality, mortality, immigration, and emigration, populations often demonstrate three phases as they grow. These three phases are exponential growth, the transitional phase, and finally the plateau phase. So if the natality, the birth rates, and the immigration rates are higher than both the mortality and emigration rates, we end up starting with an exponential growth. But if this only lasts until the emigration and the death rates start catching up, and that's what we call the transitional phase. So once all four of these factors start balancing each other out, then we end up with a plateau phase where the population stabilizes. We often refer to this as the population's carrying capacity. So because of the shape of this curve being an S, we often refer to this S curve or population growth as a sigmoid growth.